So these problems here, we need to follow the same pattern to figure them out, which is namely factor out the GCF, check if it's a difference of squares pattern or a perfect square trinomial, apply the factoring patterns, or factor by grouping. Right, so one at a time. You just got to go down the list. And so this one here, before we can check any of those patterns, we need to get rid of the fractions, right? So we can do that by multiplying the entire equation by 3 to get rid of this fraction, and then we can multiply the entire fraction by 9 to get the entire equation by 9 to get rid of this fraction here. So let's start by multiplying everything by 3. It's going to be 3 times y squared minus 4 over 3y plus 4 over 9 equals 0. So we're going to get 3y squared minus 4y plus 12 over 9 is equal to 0. Now we need to get rid of that 9, so we're going to multiply the entire equation by 9. So we'll get 27y squared minus 36y plus 12 is equal to 0. Okay, so now that we got rid of all the fractions, we're going to go ahead and follow these steps, factor out the greatest common factor. So here the greatest common factor would be 3. So I'm going to factor out a 3, and I'll get 9y squared minus 12y plus 4 is equal to 3. Alright, so now looking at this polynomial inside of the parentheses, I can notice that my first term is a perfect square, and my last term is a perfect square. And b here, this second term, is the first term times the second term, the square of the first term times the square of the second term times 2. Right. So looking here, I can tell that it is a perfect square trinomial, and it fits this pattern here. Okay. Let me go ahead and show you. We're going to go ahead and figure out what a and b are. So we have a squared is equal to 9y squared. Right. So what are we doing here? We're taking the first term and we are setting it equal to a squared. Right. A squared is equal to 9y squared. Take the square root of both sides, and we'll say a is equal to 3y. Now we need to find b the same way, so we're going to say b squared is equal to the last term 4. And then we're going to take the square root of both sides, and we'll get b is equal to 2. So we have a and we have b. And then we can double check that it fits the pattern by multiplying these two together. That's going to be 3y times 2 is going to be 6y, and multiply that by negative 2. So 6y times negative 2 is negative 12y. That's the middle term. And so that fits our pattern here, right? That this middle term is negative 2 times a times b. Right? Negative 2 times a is negative 6y times b is negative 12y. That's the middle pattern. So we can go ahead and write our factors as a minus b squared. So it's going to be 3y minus 2 parentheses squared. All right. So now we're looking at this one out here, and this one actually fits a completely different pattern that's introduced in the book. So the way that we complete these is right here, right? The square root property. And so what does that state? It says that if x squared is equal to n, then what we can do is take the square root of both sides of the equal sign and figure out what x is. So in the case of this problem here, our x is going to be this term here, z plus 3, right, is squared. So to figure out what z plus 3 is, we can take the square root of both sides. So let me go ahead and do that here. We'll take the square root of the left side, square root of the right side. And this here turns, the left side of the equal sign turns into z plus 3. So we're going to say z plus 3 is equal to the square root of 26. And let's figure out what is the square root of 36. Okay, I guess we can leave it as the square root of 36 because I don't have a calculator with me. But now to solve for z, what we need to do is subtract 3 from both sides of the equal sign. So we'll be left with z is equal to negative 3, and it's going to be a plus or minus square root of 26. And we say plus or minus because the square root of 26 can be either a positive or it can be a negative term. Okay. So now we're going to come down here, and z is equal to negative 3 plus or minus the square root of 26.